Hello, seventh grade. We're in week 16. It's kind of exciting. This is the last week, the last school week of 2020. So we're going to be talking about some geological properties. And as part of that, we want to be able to explain the phenomena of interplate activity. So why does some geological activity take place away from plate boundaries? So we've got two pictures here. And the geological activities in these photos are not at plate boundaries. Does that mean that plate tectonics is wrong? Well, no, actually it doesn't. And this activity can also be explained. It's the result of hotspots. Two hotspot locations are on the left in Hawaii and on the right in Yellowstone. Most geological activity takes place at plate boundaries, but some activity does not. Much of this interplate activity is found at hotspots. Hotspots are plumes of hot material that rise through the mantle. Hotspot volcanoes erupt when the hot material melts to create magma. Many hotspots appear to be fixed in the magma. This means that they do not move relative to each other. Plates move above the hotspots, but the hotspots stay in the same place. This feature is very useful as a tool for scientists. A chain of volcanoes form as an oceanic plate moves over a hotspot. This is how it happens. A volcano forms over the hotspot. Since the plate is moving, the volcano moves off the hotspot. When the hotspot erupts again, a new volcano forms over it. This volcano is next to the first. Over time, there is a line of volcanoes. The youngest is directly above the hotspot. The oldest is farthest away. The Hawaii Emperor chain of volcanoes formed over the Hawaiian hotspot. The Hawaiian Islands formed most recently. Kilauea volcano is currently erupting. It is over the hotspot. The Emperor seamounts are so old they no longer reach above sea level. The oldest existing of the Emperor seamounts is about to subduct into the Aleutian Trench off of Alaska. Older cones may already be in the trench. Geologists can get age dates from the volcanic rocks that erupt at these hotspots. So they use hotspot chains to tell the direction and speed a plate is moving. Hotspots are also found under the continental crust. Since it is more difficult for magma to make it through the thick crust, they are much less common. One exception is the Yellowstone hotspot. This hotspot is very active. In the past, the hotspot produced enormous volcanic eruptions. Now its activity is best seen in the region's famous geysers. Here's another picture of Yellowstone. And you can see the various places where the hotspot has been over time. Not all geological activity is found at plate boundaries. Activity within a plate is called intraplate activity. Most intraplate activity occurs at hotspots. Hotspot volcanoes erupt mostly on oceanic crust. A few hotspots erupt on continental crust. The difference is due to the thickness of the crust. Hotspots can be used to tell the speed and direction that a plate is moving. So, at this point, you should be able to explain the phenomena of intraplate activity, how it happens, and why it happens. If you can do so, please move on to the questions. Please remember that as you move on to the questions, you will not be able to come back to this video. So if you want to go back to the video at this time and take notes, you most certainly may. Have a great day. We'll talk to you later.